Okay. Well, welcome everyone. Before we commence our next YLab seminar, I'd like to acknowledge that we're on the lands, or the Parkville and RMIT campuses, on the lands of the Wurundjeri people who have been custodians of these lands for thousands of years, and acknowledge and pay our respects to their elders, past and present. So our YLab webinar today is being given by Liang. He's the co-founder and CTO of KDH Design, and Younger has been an innovator with over 25 years of experience working in a range of sectors, from consumer, industrial and military segments in software and hardware integration. So I think he's really well placed to talk to us about some of the work that their company is doing and some of the collaborations that they're involved with universities like the University of Melbourne and RMIT. So I'm really looking forward to hearing Younger's perspectives on a 5G enabled world. And I'll hand over now. Looking forward to your talk, Younger. For the audience, I'd ask you to please hold questions till the end of the talk. And if you want to type them into the chat as we go, we'll answer them at the end. So thank you.
Thank you guys for the opportunity to have me to share in this seminar. Allow me to adjust my equipment. Wait a minute. Okay. In the very beginning, allow me to start the talk with this picture. The gorgeous Grand Hotel located in center area of Taipei City. For this moment, I'm based in Taipei. The hotel was shut down a few years ago. It's before the pandemic, so it's about 2 to 3 years ago. But in the meantime, there are others rising. So you can see many this type of small hotels rising. So how could this type of small, medium-sized business afford? Marketing expenses required to reach the potential customers. We all know that it's because of this. Thanks to this type of new generation platforms, so they can do this with a very, I would say, budget pricing expenses in marketing and operation. So what we see here is a paradigm shift given by radical changes. And the radical change may lead to sometime a crisis. And that crisis may come with dangerous opportunities. So we see this type of things coming again and again in the development of the whole industry back to the couple of decades. So no doubt that all this artificial intelligence, artificial base or industrial internet on things type of things, edge computing, is all built on top of ubiquitous connectivity. So allow me to use this drawing to share with you guys. From my point of view, this is 5G spectrum from different aspects. To me, the most different feature in comparison with the predecessors, the 4G, 3G, things like that, is being more open. No matter from perspective of the architecture, from the deployment of all this type of required facilities to be renewed, to be rebuilt, from the use cases, from perspective of market segments. So it's not that walled garden by telco companies dominate power before. So when there is a radical change, you can see that there's a threat coming, but also with a great opportunity. So when we're talking about 5G, from, I would say, from users' point of view, they may be, this could be interpreted to something like higher speed, scaled up transactions, and lower latency. We know this quite well. So going higher frequency spectrum to carry more data is a way to go. Technically, I would say it's seemed without alternatives. And this may create some known problems. So the problem is more about wavelengths versus diffraction effect. From this point of view, from this slide sharing on the screen, unless you have to have the wavelengths make it longer than the obstacle for the wave to go around the obstacle. Otherwise, there will be no signal. The signal will be simply blocked by the obstacle. And let's take a look at the behaviors of the soldiers. So they are basically hiding behind the wall. So why? Because they could be protected from the bullets. And standing behind the wall, they can still have a clear idea about what's happening on the other side of the wall. So this is, we know that this is simply because of the wavelength of the sound wave is much, much longer than the scale of the wall. So the sound wave can just simply go around the wall by, as we said, it's a diffraction effect. So we like the turning angle. We like the result caused by diffraction effect. But when you think about the scale of the wavelength and the obstacle, that could be a challenge, I would say, to overcome in some different type of product design. So small cell, this type of new type of could be considered some sort of access point, some sort of relay repeaters type of devices is playing the essential role of enabling 5G as expected in terms of the end user's experience. So definitely more access points to be deployed is required to install everywhere. I would say maybe every block we have to have at least one this type of small cell. Otherwise, the coverage will be poor. So you can see that from this picture, the signal noise ratio is not that okay if you would like to have the coverage over the building, not only on the street. The high frequency, we know that it's not something like to take over the existing facilities, but could be considered as a complementary. As I mentioned that because of the pandemic, for this moment, we are here based in, basically block in Taipei. I would like to take this, basically it's a screen capture from a web page from the telco company. This is, from here you can see that we have 5 major mobile carriers here in Taiwan. And this is for your understanding about the deployment of 4G LTE facilities in a small district in Taipei. Talking about the size, it's about 10 square kilometers about the size. So we have about a few numbers of base stations over there. This is quite okay for the service of the quality from end user's point of view for this moment. But when we go 5G, definitely we need more, 10 times, maybe 100 times. Otherwise, you won't have to be able to have the similar, or I would like to say something like a wish expectation from the end user for the high speed type of connectivity experience offered by 5G. So certainly it's going to have to build up more this type of small cells. And certainly it's going to create some more opportunities, not only on the hardware side, but also on somewhere else. So this is for everybody's better understanding about the form factor. Basically, the size of the small cell type of devices is quite I would say it's quite okay for the installation with the street lights. So from a real estate point of view, the ownership of this type of street lights belongs to the government. So the buildup of 5G infrastructure to offer wireless connection type of things is supposedly ideologically and politically feasible, better feasible to go. So not a surprise that already there have been some suppliers already on the market. And some of them, they were not in the telco market in this segment's business before. So basically they are new to the market in the past. It's dominated, controlled by telco companies. And if we take a closer look at the top left corner of this slide, so you can see many, I would say, promising data, promising numbers to convince you that the future of this type of opportunities is quite bright. So there are certainly great opportunities over there because of the strong needs to enable a better persuasive 5G coverage. So we can for sure find out many things like this look promising in the new deployment of this type of opportunities in 5G ecosystem. And now we can have a look at the projection. So the projection curve looks promising as well, as it should be, right? And we have to say that it has to be going up like this way. Otherwise, no one will pay for the report. So you can find many this type of data reports, survey on the market to show you how promising the future will be. And if we take a deeper look into the report, the projection back to last year, 2020, it looked like, I won't jump into the details of this type of numbers, but I would rather like to make a comparison of the last year one and this year. So you can see that with those type of highlighted keywords, enterprise small cell, diverse requirements from different industries, open small cell architecture, small cell deployers, blah. So it indicates that from the new development of this type of new devices coming into 2021, with the newer updates, looks like the opportunities to date, at least to date, is more on enterprise segment. And then allow us to take a look at the key components, conceptually, key components in general required to launch any kind of IT-powered services. So from left to right-hand side, they are more on infrastructure, could be considered as something like the underlayer platform. And in the middle is client-side devices, no matter it's handheld, no matter it's in form factor of something like wearable type of computings. And on the right-hand side, it's going to have more devices to be installed around the users. So the user basically is surrounded by different kind of devices. So why? Because with only the client-side devices, without the help from the surrounded devices, you can't offer a decent inside out with outside in simultaneous type of, in terms of a user experience, it's something situational awareness for the computer system to understand the situation of the user and to be able to push back the required rendered imaging for end user to interact with So this is quite easy to understand. For any kind of services, we have to have this type of devices to work together to enable the service. And once we have on the left-hand side, once we have the infrastructure, the base, I would say the service play layers, something like to offer the access service for the upper layered components. Once it's ready, certainly we will see more and more different type of applications are built on top of it's basically something like a platform. So you can have your application focusing more in industrial type of use cases. So you can design the system with different type of sensors and to get the data collected, captured from the sensor fusion and working together with edge computing. So tier by tier, you can have the data to be processed in different layers. And then you can have a better understanding for your day-to-day operation. So this is going to be very helpful for the operator, for the owner. Implementing this type of interoperability things through APIs, application programming interface, to collaborate with existing facilities, devices, machines, and services is technically feasible. It's basically it's not a big deal. So which is not considered to be the main blocking issue to enable a new generation 5G powered services. No matter it's AR, no matter it's sensor fusion type of services. So this is a real case, managed and designed, engineered, deployed, maintained by Jarvish. So we offer it's smart warehousing for government. And what you can see that the dot line, the light blue line here. So once you have this type of decent connectivity, no matter it's for data communication, no matter it's for precise positioning, no matter it's for detection. So once you have the infrastructure ready, so you can have different type of applications like automated guided vehicle, AGV. You can have situational awareness for the AGV, for the devices installed on AGV to interact with the shelf, with the operator. And this can be developed further on different type of middleware to integrate with, for example, the backend SAP system or different type of backend already running on the customer side. So in this case, the middle tier is built on top of robots operating system, ROS. So we use the messaging system to bridge all this type of different type of data coming from different type of devices installed around the environment. So talking a little bit about the very different use scenario, transportation, it's not that the same as industrial, for factory, for warehouse. So if you have only in-vehicle devices functional on the client side only, so nowadays we have all these type of cameras, ultrasonic sensors, LiDAR, ultrasonic, all these type of visible light, invisible light in form of different wavelengths. So this type of, I would say maybe over 20 sensors installed with your car. But only with this type of devices and the, actually it's powerful enough local computing power, horsepower installed within the car. The inside out situational awareness from user experience point of view, it's not that good enough. But considering that little by little, if we have one day some more facilities installed surrounding, so in that case, the outside-in simultaneous awareness will need to, for sure, to build on top the connection enabled by vehicle to vehicle or vehicle to X. X means anything else. So nowadays it's more roadside unit. It's some sort of street lights, that type of facilities. So once we have this type of things ready, we'll be able to offer a better persuasive ADAS. And in that case, the smart enough transportation experience can be offered. As for AR, augmented reality, it's called metaverse recently. It's hot. And it has been on the market for years. But you actually don't see this type of things around. Unfortunately, when we talk about AR, it's not realized. It's still far, far away from reality in daily life. I will take a deeper look at this later on, after a few slides following. So a very quick summary, talking about 5G and new devices required to be installed along with the development of 5G network. So far, the deployment to be able to make real profit so far, we have to say that it's still more on the enterprise applications. And along with the buildup of the 5G powered, very strong, powerful infrastructure getting better matured little by little. In the meantime, the client side is getting ready. Different form factors of the new generation devices is getting ready by degree. So this is a very quick example for your reference. We take use of the one single front view camera. The camera is seamlessly integrated within the Jarvis branded smart helmet. We take use of the image captured by the camera to do scene reconstruction. That can even be done through the visible light imaging only by one single camera. And as far as I could remember, that the team members, they used maybe just a couple of weeks to have this done for a government project. So you can understand that how many this type of open sources on the market could be used for the devices to come out a better total solution for the customers on top of the so-called ubiquitous connectivity offered by the next generation wireless connection. But by looking around, we can have many, many different types of ideas, not only on the development of new devices, but also on software, on algorithm, on service type of things. But looking around, we all should agree to that people are not that interested. They are basically not that feeling excited about 5G. So from inference powers point of view, this is only from my point of view. It's seemed far behind from the experience, the 3G moment, many, many years ago. So Apple is smart. So back to 2 years ago, along with the new development of 5G to be deployed to the market by the major mobile carriers on the market back to 2020. So Apple was not selling 5G the very first time with the debut of iPhone generation 11. So why? It's simply because of the user experience design. Moving on from, for example, as we mentioned before in this talk, from industrial applications, if we would like to move on the user experience design to any consumers, this is not just a copy and paste. This is not just something like a collection, like a reorganization of the data sheet for features, benefit type of things. I would like to take in the very well-known blind spot alert application as an example. So the blind spot alert on side mirror, this is doing quite good on 4 wheels vehicles. I would say that this is almost becoming something like a standard option for even budget pricing cars nowadays sold on the market. So for 4 wheels, it's totally okay. It's quite welcome by end users. And I would say that it must save some lives. So that's quite good. But in the case if you are going to take the same thing to be applied to 2 wheels, motorcycle type of vehicles, that may cause some problems. Considering that the driving behavior of motorcycle is something like this, it's changing lanes frequently, and this is not going to against the law, because according to from the government's resource point of view, taking this type of driving behavior, changing lanes by motorcycle is going to optimize the use of the space of the road. So because of this, the typical blind spot alert type of a system won't work for 2 wheels. So the engineers will need to take more about the use scenarios into a consideration for this type of, I would say, feature design to move on to a different use cases. So all in all, again and again, the adoption is still about the end customer's benefits. So if the next big thing is AR, is 5G, then I would say, how come it's big? If it's big, then it must be something to do with consumers, mass market, right? But nowadays, when we talk about AR, when we talk about 5G, it's more on industrial, more on enterprise, but it's rarely could be found in consumer segment. So from our point of view, back to 6 to 7 years ago, when the company was first founded, we respect that we must learn something new from the real deployments. So that's why we picked this quite, I would say, niche market. Basically, it's doing smart wearable, or it could be known as head-worn type of devices for motorcyclists. The taking use of this smart new generation wearables, if you can offer a persuasive, I would say, benefits to the riders, and considering that the riding environment is outside, is tough, the environment is challenging in terms of humidity, in terms of shock, vibration, in terms of the very complicated light situation. And for sure, it's very noisy. And the noise not just comes from ambient environment, but also from the wind. So all these type of things together, making it super, super challenging to design a persuasive device to be able to not only to showcase what you can do, but to offer the features and service for the riders for years under maintenance, under return material insurance type of binding agreement with the end users. So we selected this niche market to test what's really required, what has to be avoided from the design of the smart wearable type of devices. So we have many this type of smart helmet with different form factors. So those type of products sold to the market on a yearly basis with new generation in the past couple of years. And our smart helmet was selected by Amazon. Basically, it's with the other 9 products in the list. The event was held in London. I miss London. everything, including transportation, everything, including even foods. Basically, the selection process by Amazon is out of millions of products on Amazon platform or around the world for the most wish one, to find out the most wish one for the Christmas event. And 2 years later, we won CES Innovation, the most innovative award from CES. So with AR, augmented reality, the computer rendered objects can then really interact with the real objects in the real world around the user through users' behavior to interact with. So that's what AR doing. We devoted ourselves to hardware, smart devices development, including not only the hardware design, not only the optical design, software design type of things, but the hands-free man-machine interface logic to enable the operation in real worlds. So AR, augmented reality, sounds great for end users, and it's also playing quite, it will, if it works, it will play as a very important growth engine for IT industry after PC, smartphone era. But things just are not going as expected because of, you can see that from optical engineering design's point of view, you just can't make it with bright enough display experience. You can make it with affordable pricing. And because it's all made by glass, it can't be flexible. It has to be made flat. So it's not that okay to pass. For example, drop test, shockproof type of certification usually is required for general electronic consumer electronic type of devices to be sold on the market. And from user experience point of view, it's even worse because as you can see that from the top left of the drawing, so the light beam generated by the optical engine need to be guided into the same waveguide. Usually the thickness is at about less than 1 millimeter. And you have to magnify the imaging. You have to do all the mechanism to make sure that the imaging's integrity is maintained within the light beam traveling inside the waveguide, all the way from couple-in edge to couple out, to penetrate out from the waveguide to end users' pupil. And because of the difficulty of the optics, of the wave optics theory used to design this type of optical design, so typically the field of view, FOV, the I-box means the active area of the image placed in front of end user's eyes. So from this active area, the imaging could be projected to end user's pupil. And given that the eye box is quite small, usually it's at about 1 centimeter by 1 centimeter. So it turns out that the form factor, the glasses, which is that not comfortable from end user's experience point of view. So it needs to be very close to user's eyes. Otherwise, there will be no way for the end user to see the image. And usually, you have to have this type of optical engine placed attached basically to the waveguide, as we can see here, at the lower bottom edge of the slide. The black part is something like a tiny projector. Functionality-wise, it's the same as the projector installed on the ceiling, but the size, the optical design is totally different because what we can see from this type of waveguides is a see-through image. So for see-through image, it needs to be virtual. It's not a real image. So the optical design of the projector is very different with the typical projector. And because of the optical design principles of all these type of AR waveguides sold on the market, it's not that okay, because you can see that most of them, they take use of a diffraction effect for the light path design. And you know that the performance, which means that a lot of energy will be lost by diffraction effect. So it turns out that as a result, the final come out from the waveguide, the brightness won't be that good enough for any user to see the image. If you are going to use these type of things outdoors, it will be a disaster. So how to overcome this? Engineering's point of view, it can be done very easy to drive the power of the tiny projector, the light beam, to stronger enough, but that's going to consume more power. And remember that we are talking about wearable design. So this is going to be a disaster for the product design. So all in all, as a result, all these type of devices, they are so expensive. User experience-wise, it's not that okay to accept. And as a result, so they are basically not good at all. So can we make something better? Can we make something cool? So we devoted ourselves to head-on devices development, including, as we mentioned before, hands-free man-machine interface and AR type of design. So without AR, without optical design, there will be no chance for smart wearable to be able to see images displayed from the system on the go, on the move. So this is so important to make a smart wearable to another level. Without this, with only audio system, with only some kind of sensors to better understand end users' behavior for gesture control, something like that, you can't offer the user interface design to another level. So we started jumping into AR optics back to 2014. So you can see that we have many different type of optical design. Some of them from left-hand side, the first one, the second one, and the third one is basically the first two is done by us. The third one, we try to work together with Lumos, but unfortunately it's failed to be able to make the product pass the required certification. So later on, after that, we have to go back to use our own design, to do something wild, to do something ambitious, to see if we can overcome the problem, the difficulties nowadays with the waveguide design. So it's very happy that we have the opportunity, we have had the opportunity to have University of Melbourne and MCN. MCN stands for Manufacturing Center of Nano Fabrication, something like that, based in Melbourne as well. So it's very happy to have their support. So working together with WE department of Melbourne University, University of Melbourne and MCN, help us not only in fabrication, not only in process of this type of optical materials, but also in IP, but also in engineering, but also in design type of things. So it's very, very appreciated. So we talk about fabrication, we talk about manufacturing of all this type of microstructure to enable waveguides. It looks like this. But fortunately, the scale of the microstructure in our case is micrometer, it's not nanometer. Because as we mentioned that what you're going to handle is visible light. So to handle the wavelengths of visible light, then the manufacturing is doable by the industrial process because the scale of the microstructure won't be something like this for semiconductor. So this is an overview of what we are working together with the team. So the code name, the name basically is not only for code, it's for marketing as well. It's called Tiger Display. So it's a short of transparent integrated guiding enhanced reality film. So basically it's a film. So from this picture in the middle, the light blue part, transparent, underlayered, the gray layer on the top is for switching control to be able to control if you allow the light beam to be penetrated or to be blocked. So you can take use of many different types of mechanisms to do this. And the underlayer is film. Film, because it's film, so it's passive. So the role of the film is to allow the light beam generated from the light engine placed in this slide on the right-hand side. So it's generated by scanning mechanism in one dimension. So with this range of the light beam scan generated by the light engine, and we have the film to guide the light all the way from the coupling edge to the upper layer, switching control layer, and then taking a careful, well-designed organization to reorg the light beam to form the pixels, what we want to form the final image. So basically this is the architecture, this is the theory behind. And the prototype done in last year, showing that any given pixels on the right-hand side could be regenerated by the architecture. And it's very happy that we are making some great progress along with the engineering development in integration of optical, mechanical, electronic, and software aspects of it. So given the light source can be organized with focal free, and considering if it's focal free, so the imaging could be formed at any user's pupil. So that is going to much simplify the architecture for near eye type of applications. So the architecture here by target display is not only for far field, for typical type of semi-transparent display, but we foresee that it could be used for near eye type of product design. And considering the strengths and color is already organized, prepared before the light beam coupling into the waveguide. So we can further simplify the stacking structure of the display. If we take a look at it in comparison with a typical TFT LCD type of design. So how come it's required to have this type of see-through semi-transparent display? So you can use it for car, not only for inside, but for outside, because it's a film, a light guide. So the light traveling design within the light guide can be bidirectional. And it could also be used for this type of smart retailing use cases in the near future. Considering that the offline source is going to face a very strong competition from the online stores. So how could they respond to users' behavior to the new updates from the market as fast as possible? If some kind of typical type of a paper print label is still used for this type of applications, retailing applications, then there's no way for them to have a better development to compete against. So with the semi-transparent, with the shelf bar type of display, and with the film to be able to interact with the end users, not only by visible light, but also by invisible light, then we can better understand, to help the shopper, to help the operator to better understand end users' behavior. And hopefully, with some luck, we can make the wearable AR type of devices for general consumer electronics market better slick, better stylish. So one day in the near future, we hope we can make something like this. So this is the end of my sharing. Thank you for your time.
Yeah, thank you very much, Younger.
Thank you.
So there's one question in the chat at the moment related to, I guess, your impressions on whether we will see 5G in or dedicated 5G within equipment like laptops in the near future. What's your impression on the time frame that will be involved there?
It's not okay. Certainly we can and we will. Basically, it's already happened to have 5G connectivity with smartphone. With smartphone, there's without a problem at all. But to have this type of features with things other than smartphone, that's going to create a big problem. It's not an engineering problem. It's mainly from business. Because as you may know that if you want to have, for example, no matter it's a 4G, 3G, 5G, if you would like to get access, to get connection with the cell network, then you have to have the product to be fully certified by telco companies. And it's going to take time. It's going to increase the BOM cost of the product. So the data card modem type of small is something like a small PCBA to be able to mount it on the main board of a laptop or tablet. Or it can be done as something like a plug-in card to enable the 5G, for example, connectivity. So engineering point of view is quite easy, but usually from the customer, from the brand customer's point of view, they won't do this because it's going to harm the time to market of the product design. Because as you may know that all this type of laptop, this type of tablet is going to stick with the newer generation of the main application processor unveiled by, for example, Intel, for example, by Qualcomm. So once they lose the right time window for launch in the very beginning to spend some more time on certification and regulation type of things together with the telco company, then they are going to face a big problem to sell the product to the general market. So that's what I see to share with you.
Thank you.
Okay.
Do we have any other questions? So there's one that's just been posted. Do you see a possibility of using small cell 5G or something similar for inside office buildings for the purpose of improving operations and maintenance around building management?
It's actually it's already there. So the small cell type of I would say that if we have a chance to take a deeper look at the finance book of all these type of manufacturers, they are doing business on top of small cell manufacturing, I won't be surprised that the main stream of the revenue come from all these type of small cell devices is for industrial. So for industrial, it means that it's not only for outdoors, it's for indoors as well. So I won't see any difficulties, any problems to have this type of things installed, not only together with the street light, but it could be installed, for example, on the building window, for example, for indoors, for office site type of applications. Technically, this is totally doable.
So I guess in a similar vein, I think manufacturing and I guess manufacturing 4.0 is consistently brought up as a potential use case for 5G. Where do you see the big advantages of 5G over 4G in that sector? I think that was a slide that you had quite early on in your talk.
I would like to say that it's not only for things like super bandwidth, but also taking use of the new features introduced by 5G. You can have, for example, precise positioning. When we talk about positioning, it's something like centimeter level of precision in positioning. We can have, for example, very low latency over by 5G. So you can for sure have these types of things offered by the newer generation of Wi-Fi. But according to our what we learned from the real case, if you are going to install all this type of, for example, 8011 based access point, in comparison with a simple 5G base station on site, in comparison, cost management point of view, 5G definitely is going to have a best position in comparison with the old, I would say, wireless architecture. So it's not only for bandwidth, but also for something else. And it's also quite, I would say, in terms of the deployment to the site, in terms of time, all these type of radio frequency bands building on top of 5G is in license band. So for the end customers, they won't have any issue to install these type of things on site, working together with their existing facilities. So this is already happening, and people are looking for something else, not only the speed, but also different type of applications on top of the 5G architecture. But again, for this moment, it's still more on industrial. It's rarely to be found in consumer segments to date.
So there's a couple of questions about the helmet that you presented today. I think a few people are quite excited seeing some of those images. But one question, how much compute capability do you have inside the helmets? And is, I guess, the computation being done at the edge or inside the helmet, or is information being transmitted across to a base station?
Okay, allow me to switch to the transportation slide. Wait a minute. It's going to be closed. Okay, this one. Okay. Talking about the head-worn wearable design, if we are going to have, for example, a decent voice command system, you have to take the use case, the situation around the user into consideration. Because in this case that if you are doing voice command indoors, which means that you can always have quite okay in terms of connection to internet. So all this type of features provided by standard Android framework, standard application interface offered by iOS, you can use it to enable your voice command based applications. But for writing, case by case, you may lose the connection. So which means that in that time, you still have to have the voice command system work. So taking our design into example, so we have two different design. One is based on keyword, based of voice command. So which means that a micro MCU type of computing power is going to be good enough to handle something like 40 or 50 keywords based on voice command system. So for things like, for example, like take a phone call, something like volume up, volume down, this type of a very quick command, this can be done very well. But if it's going to be something like, hey, Google, I'm feeling hungry, can you do something for me, something like that, you have to go through internet. So our system usually is something like a two separate system. So we have one for essential. So it's MCU based. It's very, in terms of power consumption, it's very low. And the other thing is if you would like to have something like navigation, if you would like to have full functionality on top of event recording, for example, something like to understand the road sign, artificial intelligence type of things, then you definitely need to have something basically equal to nowadays, those type of, I would say, used by mobile phone. So by mobile phone, we mean something like the CPU is, for example, Qualcomm, Snapdragon, 8, for example, 65, 880, XR2, this type of computing power, which will be good enough. But if you are looking for something like for voice handling, if you are looking like something like for understand the situation of the riders, so if something happened, they could be found, or they could be connected from the located by the system, then an MCU-based system will be good enough. But talking about all this type of computing power for computation is not a big deal for the helmet design. We consider that the helmet is form factor-wise huge, right? It's not that glasses. So still you have some space, you have some room, further room, no matter it's for the space of all this type of electronics, but also you have some space for the weight of the battery pack. So probably I would say something like 3,000 milliamp hour battery pack, the size will be good enough for what I was talking about, no matter it's for multimedia emphasized applications or it's for low bit rate data computation, it will be good enough. The most big, I would say the biggest issue is, I would say it's not this type of computer computation type of jobs, but it's more on display. So if you would like to have a display for the rider, for the helmet design, as we mentioned, that the optical performance nowadays built on top of no matter it's a holographic based or diffraction based optical design, you could imagine that the number. Imagine that you have, for example, 100,000 nits of the light of the image to be coupled in, and at the end, with a two-dimensional pupil expansion, diffraction-based optical design in the waveguide, you may only have something like 200 or 300 nits to be coupled out. So you can imagine that how much battery power will be required for the waveguide. So that's why for all this type of AR devices, if you would like to have a display feature, then the big problem will be more on battery power. If it's only for something like to control music, to do video recording for event, for sharing the fun moment, to be able to locate it in the case that if there's any emergency, to better understand the system working, something like that, it'll be easier. So MCU-based type of design, good enough, because you can always have, for example, BLE, Bluetooth type of connection with earphone. And the earphone, when you are riding, maybe it's not in your pocket. It's through some kind of a mechanism to be mounted on the handle. And on the handle, you can have power supply from the back. So that won't be a problem. And in between, there's Bluetooth, there's BLE only. So the data rate considered is quite low. So for low power consume type of a system design, or for a higher, it won't be a problem. But for display, as we mentioned, it's super difficult from the system design, because you won't have the space, and you won't have the chance for a user to wear something like a helmet with a weight over, for example, 2 kilograms. I would say the upper bound for helmet type of design will be something around 1.5, 1.6. That's the maximum. And with this weight, you have to have used, for example, carbon fiber type of very lightweight structure to do the shell design, to squeeze the weight space for the battery. And it's going to be very expensive. And it's going certainly to harm the deployment of this type of devices for general public. So that's from my point of view for your information.
Thank you. So we might just wrap up with one very quick question, which is when will the AR head-up display be ready for the market? When do you expect to launch?
There are already some on the market, but because of the low optical performance, so you can see that the form factor-wise, it's not that friendly, it's not that comfortable from end users' expectation. So it's already there. It works. It works for specifically for some purpose, for domain type applications, like for industrial, for training, for learning. People understand they have to compromise with this. But for general public, I would say that still there is something like maybe at least 3 or 4 or 5 years to go to see this type of things on the street by end users. This is from my point of view for your information.
Okay, so I won't put it on my Christmas list for this year.
No.
Well,
No.
Let me draw the webinar to a close now, Younger. I'd like to thank you for your time and your presentation.
Thank you.
It was really enlightening, and we really appreciate it. So
thank you.
Thank you very much.
Thank you, guys.